It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators. Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this.
Welcome to Unacademy. Welcome to Unacademy Semester Exams. We are dealing with the control systems quick revision for the semester exams, Chapter 2 as a part of Lecture 4. To start with, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked the GATE. Unacademy, let's crack it. Crack GATE and ESE with India's largest learning platform, and you can install Unacademy learning app from Google Play Store and you get these daily live classes, structured courses, live test and quizzes, unlimited access. Also, we have personal coach, study tracker, mains, question and answer, and all benefits of Plus in Iconic subscription. Also in Plus subscription, you have daily live classes, structured courses, and live test and quizzes, and unlimited access as well. You can learn from the top educators of the Unacademy, as you can see, and you also have GATE and ESE batches and year-long courses for all the specializations and all the subjects. In Iconic subscription, you have all the benefits of the Plus, as you can see. Also personal coach, personalized test analysis, study planner, preparatory study materials, and many more in Iconic subscription. So I better choose Iconic subscription for the students, the suggestible one. In Plus subscription, if you are opting for Plus subscription, I suggest you to go for 24 months, and you can use my code YSK10 to get the maximum discount, that is 2 for the limited period of time. And you can also opt for the Iconic subscription, which is one of the best for the students. You can use my code YSK10 for 24 months subscription, and you can get discount on this, and this is also for a limited period of time. And now today we'll deal with the control systems Chapter 2, RH criteria and root locus. Let me tell you, we have discussed something in the Chapter 2. Because this is a quick revision, we have the Chapter 2 Part A. In the yesterday's session we have done this Part A, and now today we'll be dealing with the Part B. As a part of Part A, we have done the time response of second order under damped system, time response of second order under damped system, and also we have seen time domain specifications. Those who did not watch my session yesterday, you can watch this session. These are one of the important questions for your examinations as far as semester is concerned. Lakshman, hi, and SBS Online Education, good evening. Welcome to Unacademy. Also, we have learned what are static error constants and steady state error constants and steady state error, and we have solved some problems based on these topics as well yesterday. So as a part of Part B in Chapter 2, we will learn Routh-Hurwitz criteria and also root locus. Let's see. First, I'll teach you what is the procedure that you need to follow for Routh-Hurwitz and root locus. Then we'll move ahead with the problems or the university questions that are previously asked. So let me start with this RH criteria. So the first basic point about this is it is used to find the stability of a given system. Stability of a given system. And using this, you can say that it is based on the array, a Routh's array called as the Routh-Hurwitz array. And based on this, you can say number of poles and zeros on left and right, sorry, number of poles, not about the zeros, number of poles on left and right half of S plane. And you do not know the exact location. You must observe that no exact location is determined. This is one of the disadvantages of RH criteria, you can see. Then coming to this RH criteria, you will have basically you will have two difficulties, but I'll take this term as 3 to 4 cases. So we will study this as 4 cases. Like, let me explain you that. First we will construct an array. Let's say I'll tell you how do we construct this array. Right? Let's say I have this array. Let me take one example. Let's take s power 4, or let's take s power 5. That will be better. S power 5 plus 7 s power 4 plus 3 s cube plus 8 s square plus 9 s plus 11 is equal to 0. What we do is we will just construct this array as s power 5, s power 4, s cube, s square, s power 1, s power 0. We write these coefficients of these terms here. Let's take the highest power is odd, so we'll consider all the odd powers first. Then we'll consider the even powers, even coefficients, and we write them here. I'm not doing completely this problem. So what we do is we'll write here 1, 3 and 9. See, this is 1, 3 and 9 first in the first row, and in the second row what we do is we'll write 7, 8 and 11. 7, 8 and 11. We'll try to fill up this by using a simple expression. I'll also tell you that BC minus KD by C. Then let's say we have got some positive value here, we have got some positive value, we have got some positive value. And how do we comment on the stability of a system using this RH criteria is based on this first column sign changes. Right? Based on this first column, the statement is something like this: if number of sign changes, right, number of sign changes in first column is equal to number of roots on right half of S plane. Just you need to remember this expression, which is very important. Right? Shiv Kumar, good evening. Welcome to Unacademy. So if at all, let's say this 1 is a positive, 7 is a positive, and you got a positive here, you got a positive here, you also got a positive here. And what are the number of roots of this equation? S power 5. How many roots does it have? It has 5 roots. Right? And whenever you do not have, does this have a sign change here? All are positive, therefore you can say no sign changes. No sign changes. What does this indicate? Number of sign changes is 0. So number of roots on RH right half of S plane is also 0. Therefore all 5 roots are on left half of S plane. Then you can say, because the roots are on left half of S plane, the given equation is a characteristic equation, and the roots of this are called as the poles. So if the roots are on the left half of S plane, that means this indicates that the poles are on the left half of S plane. Therefore all poles on left half. This indicates that the system is stable. This indicates that the system is stable. Now let's consider another case. Let's say I've considered the same thing here. I'm just taking this. Let me consider this. Yeah. Let me consider this. Once again. Yeah. Let us take this value once again. I'm just taking this to the next slide. Right. Now let us say I have this. And let us suppose that you have got a negative value here, also got a negative value here. Let's suppose that. So while doing some calculations, you'll know that. So this is a positive value, this is also a positive value, this is a negative value, this is a positive value. Let's say here you also have a positive and a positive. Let's say this is a positive and a negative value. Now you need to calculate number of sign changes. Does the sign change from first to second place? No. Does the sign change from first to second place? Yes. Second to third place? Yes. Does the sign change? You are at minus and your sign is changing? Yes, sign has changed. Is the sign changing here? No. Is the sign changing from plus to minus? Yes, it is changing. So how many number of sign changes are there? Therefore, you should write number of sign changes is equal to what? 3. So you can see 1, 2 and 3 times the sign has changed. What does this indicate? We know number of sign changes is what? Number of roots on right half of S plane is equal to what now? 3. So what are the total roots that we have for this? Because it is S power 5, we can say there are in total you have 5 roots. They are nothing but the poles, because this is a characteristic equation that is given for us. This is a characteristic equation. So 5 roots or 5 poles, it has 5 poles, of which we have already concluded that 3 are in right half of S plane. So you can say of this 5, 3 are on right half and rest of the 2 will be on left half. Whenever you have a pole on the right half of S plane, we can conclude that the system is unstable. So let me tell you, if the roots are on right half of S plane, system is unstable. Or how did we get that roots are on right half of S plane? It depends on the number of sign changes. It is equal to the number of sign changes. So if there exist, you can say, if there exist sign changes where in the first column, this is the first column. If there exist sign changes in the first column of routes array, you can say that the system is unstable. If there are no sign changes in this routes array, then you can say that the system is stable system. If there are sign changes, it is an unstable system. If there are no sign changes, then the system is an stable system. And in some cases, what happens? Now let me take the same example. Now let us consider the same example. Now what is happening? Sometimes what happens is this will become 0 and this will be a non-zero. Let us say you have a 2 or a 3. So this row has the first element as 0, second element as 2 and third element as 3. Or this can also be a 0. Let's suppose this is also a 0. Let's say, yeah, this is a 0. Anything. The main focus should be on the first row, first column. In the first column, if you are getting the first element, any row, first element, if it is 0, first column element, if it is 0, then when you apply an expression like BC minus AD by C, what is B? This we call it as A, this we call it as B, this as C, this as D, when you are calculating this expression. Right? Now when you calculate the next expression here, you will call this as A, this as B, this as C and this as D. So when you write by C, by 0, that will not be a valid one, right? So whenever you have a 0, what you should do? This is called as the difficulty 1. This is difficulty 1. So we have discussed 4 cases. This is the first case. What is this? All positive first column. Then system is stable. Then we have discussed sign changes. Second, if there are sign changes, then the system is unstable. Then the third case is this one. Whenever the first element is a 0 element, then you should replace, this is difficulty 1, we'll call it as, or the case 1. When first element is 0 and any other element in that row is a non-zero. You should be very much careful here. If there are all zeros, that is another case. But if you have one non-zero element, either it can be, let's say first element is 0, second element is 0, third element is 2. This also comes under this difficulty 1. Let us say you have 0 to 2. This is also difficulty one because you have first element is 0 and any other. It can be one or two elements that are non-zeros, or you have 0 to 0, the one that we have taken just now. This also comes under, all these three come under the difficulty one that I am discussing, right? So let's see what you have to do then. Now, any any other element in that row is a non-zero. It can be one or two. Then you need to replace, I'm just trying to take it this way, yeah, replace 0 by epsilon and fill array. Then you complete, once you complete that array, once you are done with that array, you need to apply the limit. Then apply limit, that is limit epsilon tends to 0. Epsilon is a positive integer that we consider. Epsilon tends to 0, the first column element. Here you'll have to write first column element. Here either you'll get a positive infinity or a negative infinity or a positive value or a negative value. Most probably this will not be a 0. Once you apply this limit, based on this, what will happen? Just look at this. So you will apply, let's say I have epsilon here, I have replaced this by epsilon, and to this is a function of epsilon. Now if I apply limit, let's say this value also, this is also a function of epsilon, this is also a function of epsilon. Let's say you have an epsilon here and it's a positive value. Let's say this is also a positive value, this is also a positive value, and when you have applied limit to this, let's say this is a negative value, this is also a negative value, this is a positive value, right? These are functions of epsilon, right? Now whenever this is the case, now what happens is, in this case, do you have any sign change? No. Do you have any sign change? No. Do you have a sign change? Yes. Do you have a sign change? No. We are coming from minus to minus, no sign change. Do you have a sign change? Yes. So two sign changes, we can say the system is unstable. Or let us say you do not have something like this, instead you have all the positive values, then you can say that all the first column elements are positive and the system is a stable system. So this is the third case that I wanted to tell you. Whenever you have the first element as 0 and any one of the other elements in that particular row is a non-zero, then you need to replace that 0 by an epsilon and complete the routes array. Once you complete that routes array, apply limit. That's what we have written. You can just check it out. Yeah, this is what, right? So this can be the value. This is the third case. Now there is another case like fourth one. What happens is, we have taken something like this. Let's say this is s power 5, s power 4, s cube, s square, s power 1 and s power 0. What happens is, whenever you are trying to complete this array, you will get all zeros in a particular row. This is difficulty 2. This is difficulty 2. So what happens? All zeros in a row. Whenever you have all zeros in a row, you can say that what you have to do is, you cannot complete this array. So what you have to do is, you need to consider an auxiliary equation A of s. What is this auxiliary equation? It is a row above all zeros row. So let's say you have 2, 3. Let's say this is also 2, 3 and a 4 and a 4. You need to consider this row above this row. And what is the coefficient of this? This is s power 4 because you have s power 4. This will be s square even, and this is s power 0. You'll write an auxiliary equation A of s is equal to 2s power 4 plus 3s square plus 4 is equal to 0. Then what you have to do is, so you have to consider this. Then differentiate A of s with respect to s. So let's say I'm writing dA of s by ds. What you'll get? 8s cube plus 6s power 1 is equal to 0. Now this s cube you'll have here. See, the coefficient of s cube, you have to write it here. What is the coefficient of s cube? 8. Now what is the coefficient of s power 1? 6. Right? So then after, you need to complete the array. What do you have to do? With that, Just by differentiating and writing the coefficients in place of all zeros, complete the array. Then you can comment on the stability, wherein in this case the system will not be completely stable. Either it will be marginally stable or unstable, and that will depend upon this auxiliary equation. That will also depend upon this auxiliary equation. If all these are positive, if all the first column elements that you have got are positive, it does not guarantee that the system is a marginally stable or a stable system. It also depends upon this roots of the auxiliary equation. If the roots of the auxiliary equation are repeated, I say if this a of s is a repeated roots, has a repeated roots on imaginary axis or in the coordinates, you can say that this then the system is an unstable system. If it does not, if there are no repeated roots, you can say that the system is a stable, marginally stable system. We'll solve some problems based on this RH criteria. So finally I want to conclude with these notes, like number of sign changes in first column of Routh's array is equal to number of roots on left half of S plane, sorry, right half of S plane. That is not left, it is right half of S plane. First. Second, if number of sign changes, I'm not writing everything, number of sign changes, this indicates in the first column of Routh's array is 0, indicates system, you can say that the system is stable system, right? This is not in case of difficulty 2, this is only in the case of the rest of the things. Next, you can say then there arises a difficulty. First element 0, first element 0 and any other non-zero in that row. What you have to do, replace 0 by epsilon, then apply limit epsilon tends to 0 to the first column elements and comment on the stability. Now let's say you have one more thing, all zeros in a row. Then what you have to do, consider an auxiliary equation, differentiate it and write the coefficients and complete the array, right? So these are the important points that you have to remember for RH criteria. So let us consider one problem that I have with me, which also has been asked in some examinations. Now let us write that question. The first question is, it says that given P of S is equal to S power 4 plus 8 S cube plus 18 S square plus 16 S plus 5 is equal to 0. Using RH criteria, find its stability, or comment on the stability of the system, right? Now let us do that. First, what we will do, we'll construct this Routh's array as a part of solution. What is this? This is S power 4, first one, S cube, next S square, S power 1 and S power 0. These are the rows. Now consider this S power 4, then S square and S power 0. What are the coefficients here? Just write them. Here you have a 1, 18 and a 5. Then S cube coefficient is 8. Then take the odd terms 16. Then if you do not have anything, either you can leave it or write a 0. Now to calculate this value, listen carefully. To calculate this value, consider this as A, B, C and D. So write BC minus AD by C. Calculate this value. 18 into 8 minus 1 into 16 by 8. So once you do this, so this will give you, this is, let's try to solve that. Even I want to solve it. So let's see. So this is 18 into 18 times of 8 is 144 minus 16 by 8 minus 16 is 128. 128 divided by 8 is again a 16. So you have a 16 here. So this is a value 16. Then when you want to calculate this value, just shift this B and D to this place and apply the same BC minus AD by C. So this is 5 into 8 minus 0 into 1 by 8. So this will give you a value of 5. So this value is 5 and this is at 0. Now when you want to calculate this, just erase this all A, B, C, D, and whenever you're doing a row, you need to consider just above that row the two rows and write A, B, C, D. So write this as A, B, C and D. Now let's try to do that. So I'll erase this now as of now. Right, now let's write that. What is that? BC minus AD by C. What is B value? 16 into C. 16 minus A, 8 into 5 by 16. So let's also try to do this once again. So this is 16 times of 16 is 256 minus 8 times of 5 is 40 by 16. 256 minus 40 is 216 divided by 16 will give you 13.5. So the answer to this is 13.5 here. So this value is, let's write it in green, 13.5. Now when you want to do this, you'll just shift this B and D, and when you write, B into D is a 0 value, so you can write 0 here. Then can I write this as s power 0? Now this is what you need to do. I'll just erase this once again clearly to just make you very clear about this. Now if you want to do this, this is A, B, C and D. Now B, sorry, I've written wrongly. This is, yeah, this is B, sorry, B and C. So this is 13.5 into 5 minus 16 into 0 by 13.5. This is a 0 value, you can cancel this. The answer is 5. Now if you observe these first column elements, only the first column elements, what is the sign of this? This is a positive, this is also a positive, this is also a positive, this is a positive and this is a positive. Do you have any sign changes in this? No, we do not have any sign changes. So can we say that number of sign changes, this is NO, is number of sign changes, is equal to 0. So from this, therefore, can we say that number of roots on right half is equal to 0. Therefore, where are the roots now? Therefore, how many roots does it have? 4. All 4 roots on left half of S plane. Can I write it this way? Therefore, finally you can say the given system is a stable system. So you can finally say that the given system is a stable system. Is this clear to everyone? I guess this is clear to everyone. We have just followed the easy method and I think I've told you in a very easy way that you can understand. Alright, now this is the first question. Let's move on to the next question. Let's see. Next one. Let's move on to the second question. Let's say you have a question like this. The question is, Let me consider one question from the university question papers so that will be easy for you. So let me consider one question. Yeah. Now this is the question that is given. Uh, let's say this is the question. Question is, comment on system stability for the following characteristic equation using RH criteria. Sometimes he'll specify that, or sometimes he may not specify, and it's given as n of s is equal to characteristic equation s power 5 plus s power 4 plus 2s cube plus 2s square plus 3s plus 15. This is 3s. Let me write it clearly. Yeah, this is 3s plus 15 is equal to 0. It's not given as equal to 0. Yeah, this is the question. So what you have to do, you have to construct the routes array. So you need to write all the statements that I told you first, then you have to start solving this question. So let me write, this is s power 5, s power 4, s cube, s square, s power 1 and s power 0. Let's take it this way. Let's consider this. So what you have to do, first consider s power 5 and s cube, and yes, coefficients. Write the coefficients. Here the coefficient is 1, that is 2, and this is 3. Then consider s power 4, s square and s power 0. It is 1, 2 and 15. This is correct. 1, 2 and 15. Then you need to calculate these values. So let's write this as A, B, C and D. What is that? BC minus AD by C is 2 into 1 minus 2 into 1 by 1. So this will give you a 0 value. So this is a 0. Now let's try to shift this B and D. Shift this B and D. Shift this BD to this point. Now what is that? BC minus AD by C. 3 into 1 minus 15 into 1 by 1. So it is 3 minus 15 will give you minus 12. So this is minus 12. And you cannot calculate this value, so I'll write it as 0, or you can just leave as blank. Now what is this? This is difficulty 1. Whenever you have a 0, see in this row you have 0, minus 12, 0. In a row, if there are all zeros, you need to consider an auxiliary equation. But in this case, you have the first element 0 and any other value as non-zero. This is a non-zero. This is also a 0, but this is a non-zero. If you have at least one non-zero element, then what you have to do? You need to replace 0 by epsilon. 0 by a epsilon. So just replace the 0 by epsilon and try to find these values. Now we'll try to solve this. What do you get here? I'll just try to directly write it. So now you need to just eliminate this and write it as A, B, C and D. Now what is BC? 2 epsilon minus AD plus 12 by epsilon. This is, again you need to shift this. Yes, shift this B and D again. This is B and this is D. So BC is 15 epsilon minus 0 by epsilon will give you 15 here, again a 0 here. So just eliminate this. Now in order to calculate the value here, you need to consider this as A, B, C and D. Now what is BC? This is minus 12 into 2 epsilon plus 12 by epsilon minus 15 epsilon by, it is 2 epsilon plus 12 by epsilon. So let me just try to eliminate, we'll write this clearly. So I'll calculate and simplify and just write it. That's better, I guess. Now let's see. BC minus 12 into 2 epsilon plus 12 by epsilon into, sorry, minus 15 epsilon by 2 epsilon plus 12 by epsilon. BC minus EAD. This is BC minus EAD by C. Now if you can write this, how can you write this? Just write. Oh, this is minus 12, 2 is a 24, right? So this is minus 24 epsilon plus minus into minus again. This is minus into plus is a minus again. Minus into plus is a minus. 12 12s are 144 minus 15 epsilon square. If you take the LCM by epsilon by 2 epsilon plus 12 by epsilon, you can cancel these two, and finally you can write, what is that you can write? Just look at this. I'll just write it down. Yes, let's try to write this value. Minus of, so this is minus 15 epsilon square minus 24 epsilon minus 144 by 2 epsilon plus 12. Then in order to do this value, just erase this and write this here, B and D. Then this is the 0, you'll get a 0 finally, and s power 0 if you want to write. Consider this value as A, this as B, this as C and D. If you calculate BC, so you'll get 15 into the total value. Let's call this value as K, and this is K, or let's try to not call it as K, let's write it as P, right? So this is P minus BC minus EAD. A into 0 by C value, so that is P. You can cancel this, you'll finally get, what do you finally get here? You will get a 15 value. Now let's look at this now. So this is how you'll get. Now you should concentrate on the first column elements. You should concentrate on this first column elements and then apply limit to this. So we'll consider this, let's write this. This is a positive 1 and this is also a positive. Epsilon is considered to be a positive value. Then you need to consider this. Apply limit now. Limit epsilon tends to 0 to epsilon plus 12 by epsilon. Right? So can I write 2 plus 0 by 0 will give you plus infinity. Then apply limit to this second value s power 1 here. Right? What do you get? Limit epsilon tends to 0 minus 15 epsilon square minus 24 epsilon minus 144 by 2 epsilon plus 12. What do you get here? You can write minus 15 into 0 square minus 24 into 0. Epsilon is taken as 0. Minus 144 by 2 into 0 plus 12. This is minus 144 by 12. Will give you minus 12. So this value is a plus infinity. So I can write it as a plus value. This limit value that I have applied is a negative value, minus 12. And this is again a plus value. So I can also draw this table once again like this. So let's consider this. I'll draw this table once again in the next slide and we'll try to do that. So redraw this with these values. S power 5 4, right. S power 5, S power 4, S cube, S square, S power 1 and S power 0. Now what are the values that you have? 1 2 3 1 2 3 1 2 15 epsilon minus 12 0, so plus infinity, and minus 12 15 minus 12 15. I'm just writing the first column elements. So this value is a positive, this is also a positive, this is a positive, this is a positive, and this is a negative value, and this is again a positive value. Are there any sign changes in this? Yes, see, you can check this. This is a negative. So do you have a sign change here? No. Do you have a sign change here? No. Do you have a sign change plus to plus? No. Plus to minus? Yes, you have a sign change. Minus to plus? Yes, we have a sign change. Therefore, you can say number of sign changes is equal to what? 2. So what can you conclude from this? You can say number of roots on right half of S plane is equal to 2. What are the total roots that you have? Therefore, total roots or closed loop poles is equal to 5. Of this, you can say two roots or closed loop poles on right half of S plane, and rest of this out of 5 you have 2, rest of them are 3 roots on left half of S plane. Can we say that the system is a stable one? No, because you have a root on the right half of S plane. You can say therefore given system is an unstable system. So this is how you comment on the stability of the given system. Hope you have understood this problem. Let me just check it out once again and just give you one idea. This is the question. Now just look at the previous questions once again. Yeah, this is the first question. I want you to just recheck once again. Alright, so now let's look at the next question. This is the second question. Now let's look at one more question. Let's consider one more question. So the next question that is given is this. Let's take this question. The question is comment on stability of the system whose characteristic equation is in bracket it's given using RH criteria. Right, now let's see that. The question given is let's say the question here is, yeah, this is the question. S power 6, 2 s power 5, 8 s power 4, 12 s cube, 20 s square, 16s plus 16 is equal to 0. This is the question. Right, now let's try to solve this question. I'll just give you 1 minute of time to solve this question. I want everyone to solve this question. I'll also do this once you have started doing this. So let's solve this question. So this is s power 6, s power 5, s power 4, s cube, s square, s power 1 and s power 0. Now let's write this: s power 6, s power 4, s square and s power 0. Write the coefficients: 1, 8, 20 and 16. Next 2, 12, 16, and this is a 0. So just try to calculate this. A, B, C, D. BC minus AD by C. 8 into 2 minus 12 into 1. 1 by 2. 16 minus 12 by 2, that is 4 by 2, the value is 2. So this value is 2. Now just shift this B and D. This is B, this is D. Now let write BC minus AD again. So BC minus AD by C, 20 into 2 minus 16 into 1 by 2. 40 minus 16 by 2 is 24 by 2 will give you 12. So this is a 12. And whenever you try to shift this BD again to this, and when you try to calculate BC minus AD again, (16 into 2 minus 0 into 1 by 2 will give you 16, right? So this will be a 0 value. B and D, A and C. Now when you are finding this value here, consider this as A, B, C and D. You will get a 0 if you observe. See, B into C minus A into D by C will give you now shift this B and D. So this B is 16, C is 2, A is 2 and D is 16 by 2 will give you a 0. And because this is B and D, you are shifting B here, D here, you will get a 0 here. So if you observe this row, it has all zeros in it. It has all zeros. Whenever you have all zeros, Raju, welcome to Unacademy. What I told you was, if you have all zeros, if there exist all zeros in a row, what you have to do? Consider auxiliary equation A of S. How do you consider this? That is row above all zeros row. Right? Right? So let's consider that. So this will become enough. Now just try to eliminate this A, B, C, D. Now what is the auxiliary equation you can see? You need to consider this row. So this will become the coefficient of s power 4. This will become coefficient of s square, because this was s power 6 coefficient, this was s power 4 coefficient. So likewise, if you have even, you will have even. So this is s power 4, s square, s power 0. So from this you can write A of S auxiliary equation as 2s power 4 plus 12s square plus 16s power 0 as the auxiliary equation. Right? So now what you have to do, just try to move here. So auxiliary equation A of S is equal to, what did you get, that 2s power 4 plus 12s square plus 16s power 0 is 16. Differentiate this now. Differentiate it. 8s cube plus 24s plus 0. So you get 8s cube plus 24s. Now the coefficient of s cube is what? 8. Coefficient of s is 24. Just you need to replace these zeros. Now what is the coefficient? This will be the coefficient of s cube. So you can replace this coefficient by 8 and 24. So this will be 8 and this will be, this is, if this is s cube coefficient, this will be s power 1. So what is the coefficient of s power 1? 24. So this is 24. Now we'll try to fill up the array. Now just try to take this as, just try to remove this. Yes. Okay. Alright. Now let's consider A, B, C, D again. So this is A, B, C and D. Now apply BC minus AD by C. What is BC minus AD by C? So BC minus AD by C will be B is 12, C is 8 minus A is 2, D is 24 by C is 8. Now just try to do this. You will get 12 into 8, 96 minus 24 to the 48 by 8. This is 48 by 8. So this is 2 to 2 za, to 4 za, to 4 za, 4 6 za. 8 6 za 48, right? This value will be 6. And just try to shift this B and D. So this is B and D. You will get 16 into 8. Apply this. BC minus AD by C. 16 into 8 minus 2 into 0 by C is 8. So this will give you, this is a 0, 8 8 cancel will give you 16 and this will be a 0. Now let's try to calculate these two also. Let's try to calculate s power 1 here and an s power 0. So what should be this? So this is A, B, C and D. Now calculate BC minus AD. What is BC minus AD by C? B is 24, C is 6 minus A is 8, D is 16 by C is 6. Now if you do this, you'll get somewhere around 2.6. I'm just trying to write it directly. Then shift this B and D. So this will be a 0. And obviously, if you just look at this, you know that yes. Now this will be a 16 value. Consider A, B, C and D. Now what do you write? BC minus AD. BC minus AD by C. What is B? 16. C is 2.6. A is 6. D is 0 by 2.6. This is a 0. We'll cancel this. We'll get a 16. So finally, this is the Routh's table that you got. Right? Now check whether all the first column elements are positive or not. Check whether all the first column elements are positive or not. So let's write this. This is a positive 1, 2 is a positive, 2 is also a positive, 8 is a positive, 6 is a positive value. Let's eliminate this A, B, C, D. Yeah. And if you observe 2.6 is a positive, 16 is a positive, all first column elements are positive, but this does not guarantee that the system is a stable system, or then although these are all positive, the system may be an unstable system or it is a marginally stable system. Now this will depend upon this auxiliary equation. So let's consider that auxiliary equation. So a of s is equal to 2s power 4 plus 12s square plus 16, right? That is right, is equal to 0. Now find its root. So let's consider. So a of s is equal to, this is 2s power 4 plus 12s square plus 16 is equal to 0, minus b plus or minus root b square minus 4ac by 2a. So that is, so let's write this as, consider s square is equal to x. So this will be 2x square plus 12x plus 16 is equal to 0. So let's try to calculate this as x1 x2 first. Two roots, so minus b minus 12 plus or minus under root of b square 144, 4 into 2 into 16 by 2 into 2. So minus 12 plus or minus 16, 4 2s are 8, 16 into 8, 16 8s are 128. So minus, that is 16. So this is, yeah, this is 144 minus 128 by 2 into 2, that is minus 12 plus or minus root 16 by 4. That will be minus 12 plus 4 by 4 and minus 12 minus 4 by 4 will give you, this is minus 8 by 4 minus 16 by 4. 4 4s are 4 2s are. Therefore, you can say x1 is equal to x2 is equal to, what is x1 is equal to? Minus 2, yes, and this is minus 4. So what is x is equal to? Actually s square. So s square is equal to minus 2, s square, s1 square is equal to s2 square is equal to minus 4. What is s1 comma, let's call this as s1 s2 and s3 s4, s3, right? Now s1 s2 is equal to, what is s1 s2 is equal to? Plus or minus j root 2, right? How do you write that? We'll write it as, I'll just simply tell you this first, then we'll write that. So this is s1 is equal to under root of minus 2, this is j root 2. So you have two roots, so this is equal to plus or minus s1 comma s2. s2 is equal to plus or minus j root 2, this is one, and s3 comma s4 is equal to plus or minus j2. So what are the total auxiliary equation roots now? s1 is equal to plus j root 2, s2 is equal to minus j root 2, s3 is equal to plus j2, s4 is equal to minus j2. Are all these roots repeated? No. You therefore roots are not repeated. We have to actually know first, when the roots are repeated then the system is unstable. So because the roots are not repeated, if you get a repeated roots then you can say that the system is unstable, but you have non-repeated roots, so you can say that the system is an marginally stable system. The system is an marginally stable system. Therefore, given system is a marginally stable system. So these are some of the problems that are given in your previous university exams, right? I'm sorry. So I guess you have understood this. Now let's move on to the next topic as root locus. Let's move on to the next topic, root locus. Hope you have understood this. There is one more problem that is generally asked in RH criteria to determine the value of k for the system to be stable and all. So you can just look it because this is a quick revision. I'm just trying to give you some important note. What is root locus is locus of closed loop poles obtained when system gain k is varied from 0 to infinity. Right, now I'll not review everything here. I want to just tell you the important points. Here I would like to add one point: angle condition and magnitude condition. Before getting into the problem of root locus, why do we use this angle and magnitude condition? This angle condition is used to check whether a point is lying on a root locus or not, and we use this magnitude condition generally is used to find system gain at any point on the root locus. Now what is this angle and magnitude condition is, you just need to take for angle condition, check whether the point is lying on the root locus or not. If say if you have s a plus ib, you need to substitute this in the angle of g of s into h of s, and if this is equal to odd multiple of 180 plus or minus odd multiple of 180, that is 2q plus 1 into, you can just say like this instead, plus or minus 2q plus 1 into 180. If this is equal to, then you can say that the system is, then the point is lying on the root locus. Similarly, if you just substitute the same point in magnitude of g of s into h of s, and if that magnitude is equal to and if you equate it to 1, you can find the value of k at any point on the root locus. Right? So in this, let me tell you one example. Let me take one question first just to explain you about the angle and magnitude condition, then we'll move on to the root locus problem exactly. Now a unity feedback system, a unity feedback system has an open loop transfer function, this is given, g of s is equal to k by s into s square plus 7s plus 12. The gain for which he is asking, the gain for which s is equal to minus 1 plus j1 will lie on the root locus. For what gain that this yes will lie on the root locus. So in order to solve this condition, just consider first g of s. G of s is k by s into s square plus 7s plus 12. Then try to find its write this in terms of g of j omega. So write it as, so we have directly s, right? So we can substitute that s directly. So we just have to substitute that s. So g of s at s is equal to minus 1 plus j1, substituted k by minus 1 plus j1 into minus 1 plus j1 whole square plus 7 into minus 1 plus j1 plus 12. Right? So this is the magnitude. Sorry, this is the point substitution first. Then if you substitute this point, he is asking us to find the gain for which this s will be on the root locus. Now first we need to check whether this point s is on the root locus or not. So whenever you substitute in this, and if you apply angle condition, that is, first we need to apply angle condition. Why we need to apply angle condition? To check whether this given s is equal to -1 plus j1 is on root locus or not first. If it is on not root locus, we cannot find the value of k, right? So first, in order to check that, you need to take angle of g of s at s is equal to -1 plus j1. So if you take that angle of k is 0 degrees by angle of -1 plus j1, that is tan inverse of b by a into, what is this angle? Just if you just simplify this and find this, you'll get tan inverse of 1. So you can write this as 0 degrees by, it is a negative value, so 135 degrees into 45 degrees. So what is angle of g of s at s is equal to -1 plus j1? It is minus 180. You write this as minus 135 minus 45 is minus 180. So angle condition is satisfied. You can say angle condition satisfied. Therefore, we can say that therefore s is equal to -1 plus j1 is a point on root locus. Then you need to find the k value. So let's try to find. So to find k per given point, use, what do you use? Magnitude condition. Magnitude condition. Just take mod of g of s at s is equal to -1 plus j1 is equal to 1. So you can take k plus 0 or k square plus 0 square under root by under root of -1 square plus 1 square and under root of just simplify this. How do you simplify this? So this is -1 whole square plus j1 square plus -2j1 minus -7 plus 7j plus 12, right? So you can say so you will get this as 1 plus -1 minus 2j1 minus, so this is -7 plus 12 5 minus 7j plus 2j plus j5. So you'll get 5 plus j5 here. So you can write under root of 5 square plus 5 square is equal to 1. This implies, so this implies k square, root k square is equal to root 2 into root 50. So if you can just square it, k is equal to, you get it as 10. K is equal to 10. Therefore, you can say k is equal to 10 at k is equal to 10 at s is equal to -1 plus j1, k is equal to 10. This is the value, right? So this is how you apply angle and magnitude condition, right? Now let's move on to this root locus. Exact, how do you plot it? So root locus, I'll write all the points first. We say always root locus is symmetrical to real axis. This is the first point. Then you say that in root locus you can write The second step that you have to do is number of poles and zeros. Write it as P is equal to and Z is equal to. Third step is location of poles and zeros. Right? Where are they located? Then plot them. Plot sketch pole zero plot. We'll just write something like this. Sketch pole zero plot. Now next, then existence of root locus on real axis. Then break away and break in points. Next, you have point of intersection of root locus with imaginary axis. This all will not exist in one problem. It depends upon the given question. I'm just telling you all the points that will be that can exist in a problem which has all these things, right? Then you have, oh, we did not write that. Yeah. Before this breakaway and break-in points, after this existence of root locus on real axis, you have about asymptotes completely. So number of asymptotes, that is P minus Z. Then angle of asymptotes, that is theta is equal to 2q plus 1 into 180 by P minus Z. Then we have something called centroid, that is sum of real part of poles minus sum of real part of zeros by P minus Z, right? Sum of real part of poles minus sum of real part of zeros by P minus Z. So these are the three important things. This is completely about asymptotes. And I'll tell you how do you get this. We'll just consider a problem. You can watch my previous videos if you still have any doubts on them. On this topic, you also have a revision session on root locus which is already conducted. You can watch that video, but because this is a quick revision, we'll solve some university question paper. So after this, so you have root locus is symmetrical to real axis, number of poles and zeros you have to write, location of poles and zeros, sketch pole zero plot, and existence of root locus on real axis, and number of asymptotes, angle of asymptotes, and centroid. Here Q indicates as P is equal to, it depends upon the P minus Z. If you, its value starts from 0, 1, 2, 3 and so on. And if you have P minus Z as 2, you need to substitute Q is equal to 0 and 1. If P minus Z is 3, you need to substitute Q is equal to 0 once, then 1 and then 2. After this, you'll have breakaway and break-in points and point of intersection of root locus with real and imaginary axis. Then you have angle of arrival and departure. So these are some of the things that you need to remember these points. Now let's take up one question directly and then we'll solve that. Some university question randomly that we check. I will just check it out. Let's take one question. Sketch root locus. Define root locus. Explain the procedure. There is one question that is asked. Define root locus and explain the procedure. Let me write that question. Define root locus, that we have just done, and explain procedure to sketch. So the points that we have just discussed just now, those points you need to write all those points by explaining them. Sketch, procedure to sketch the root locus. This is one question that is given for given transfer function. For given transfer function. This is the first question. This is one question from your university question papers. I'll also pick some questions from the other. Let's take one question from the another question paper. There are some questions. Let me consider one question that is given. There is one more question like this. Explain. Sometimes the question is not being asked. Sometimes you are asked the procedure only. So you can see this procedure. Explain all rules of constructing. All rules for constructing, actually. All rules for constructing root locus of a given transfer function. Given transfer function, and this is asked for 10 marks. Just remember, this question is asked for the 10 marks, and the previous question is also asked for 10 marks. So just try to concentrate on the procedure that I told you. Right, let me check one more question paper and let's see what is the question that is given. Yeah, there is some question like k by s into s plus 3 into s cube plus s square plus 2s plus 2. This is one question. Let me also write one few more questions. Let's take one question here. The recent paper that is given is let's consider one of the recent question papers and let's see the question and then we'll solve that question. You can take one random question, but it's not always good. This is one question. Let's see, so that I can explain you all the things. The question is given something like this. It's a question from 2018 question paper. The question says a unity feedback system has an open loop function. G of s is equal to k by s into s square plus 3s plus 10. Make a rough sketch of root locus. Make a rough sketch of root locus, and the question is not complete. By determining the following. It is, first one is centroid, B is number and angle of asymptotes. Sometimes he may not give you all this, he'll just use sketch root locus, and because this is everything is given, breakaway and break-in points. Breakaway and breakaway points if any. Breakaway points if any, and angle of departure. So this is a question. So let's consider the question quickly. So question is directly I'm writing g of s. G of s is equal to k by s into s square plus 3s plus 10. So let's start with the solution first. So let's see how many are watching now. I don't know whether you are all watching me or not. So let's see. I want everyone to be active and join the session. Oh, no one is trying to watch. So let's see. So first point is root locus is symmetrical to real axis. First point. Second, number of poles and zeros. What is the number of poles? You have 3. See, these are the number of poles in the denominator, whatever you have, highest s cube. So 3 poles. Number of zeros, 0. No. Third point, you need to write all. Let's write all the points. Location of poles and zeros. What is the location of poles and zeros? So we need to find the roots. So s into s square plus 3s plus 10 is equal to 0. So let's write that s into s square plus 3s plus 10 is equal to 0. You say s is equal to 0, s square plus 3s plus 10 is equal to 0. This is one pole. So this is minus b plus or minus root b square minus 4ac by 2a. Yes. So minus 3 plus or minus root 3 square 9. 4 into 1 into 10. C value. So this is ax square plus bx plus c. C value is 10 by 2 into a is 1. Soumya, good evening. So minus 3 plus or minus root 9 minus 40 is 31 by 2. So can I write it as root 31? Just write it some value. We'll take root, let's delete everything and write this. Root 31 is 5.5. So can I write it as minus 3 plus or minus, and this is minus, right? So j 5.5 by 2, and this 5.5 divided by 2 will give me 2.7. So this is minus 3 plus j 5.5 by 2 and minus 3 minus j 5.5 by 2. So this is 2.7. You can write it as 2.8 also. So 3 divided by 2 will give me, this is minus 1.5 plus j 2.7 and minus 1.5 minus j 2.7. So poles are at S1. Let's call this as S1. S2 is at minus 1.5 plus j 2.7 and S3 is at minus 1.5 minus j 2.7, or you can take 2.7 or 2.8, that doesn't matter. So these are the poles. So this is what we have done. Location. So where are the location? S1 is equal to 0, S2 is equal to minus 1.5 plus j 2.7 and S3 is equal to minus 1.5 minus j 2.7. Clear? Yes. Now let's try to solve this. Right now, what is the other point that you can do? We'll take a rough pole 0 plot. Let's consider this. So this is 1 and this is, you can take this as 2 3 and this as minus 1 minus 2 and minus 3. Where are the poles? Generally we'll denote this poles by cross and zeros by a 0 or a circle. So there is a pole at origin and let's call this as j1 j2 j3, and this also has minus j1 minus j2 and minus j3. I'll just call this. So there is a pole at minus 1.5. You can say this is minus 1.5. At minus 1.5 and 2.7 this is 1, and minus 1.5 and 2.7 this is the one. So let's call this as 2.7. Let's also call this as 2.7 and this as minus 1.5. So I'm just taking this as minus 1.5. So this is the, what can I call this as? Pole 0 plot. Is this clear? S is equal to 0, S is equal to minus 1.5 plus J 1.2.7, S is equal to minus 1.5 minus J 2.7. After this, just try to find then what is the next step that we are, fourth step. We are in the fourth step. Let's write the fourth step as number of asymptotes. In the question also he asked us to find this number of asymptotes. What is number of asymptotes is equal to p minus z. What is p value? We already know that the p value is 3. What is z? 0. So this is 3. Therefore number of asymptotes also we have done. Then we need to find angle of asymptotes. Angle of asymptotes. What is the expression? 2q plus 1 into 180 by p minus z. How many angles you get? That depends upon this 3, right? So because you have 3, you need to take q is equal to 1, 0 and 2, right? So first theta 1, just consider 2 into 0 plus 1 by 3. P minus z is 3 into 180 will give you 60 degrees. Theta 2, substitute q is equal to 1 plus 1 by 3 into 180. So this is 360 times 3 6 are 18, 180 degrees. So theta 3 is equal to 2 into 2 plus 1 by 3 into 180. This is 60 times and 5 6 are 300 degrees. So we have asymptotes at 60, and where should we draw this? We'll draw this at centroid. We'll draw this at centroid. What is centroid? We are also asked to find this. Sum of real part of poles minus sum of real part of zeros by p minus z. Do you have any zeros? No. So this term will be a 0. Do you have poles? Yes. What are the poles? One is 0, other one is minus 1.5 plus j 2.7. Other one is minus 1.5 minus j 2.7. But we only need real part, right? We only need real part. So can I eliminate this? So and add all these. This is minus 1.5 minus 1.5. So minus 3. So what is the centroid? Minus 3. This is sum of real part of poles. Sum of real part of poles is equal to minus 3 by p minus z is also 3. Where is the centroid? Minus 1. So at this minus 1, what is this point of? This is centroid minus 1. Minus 1 comma 0. That is nothing but minus 1 comma 0 is the centroid. At this point you need to draw asymptotes with angles 60. Roughly I'm drawing it. This is, let's say this is 60, one is 180, approximately I'm just drawing it, and this is 360, right? So if this is also 300. So this is a 60 degrees asymptote, 180 degrees. It should coincide with this, and this is a 300 degrees asymptote. So is this done? Yes, it is done. Now you should identify the existence of root locus on real axis. That we did not do. So you can say that this, as we know, you can check my previous sessions, this complete path is the this complete path is the root locus. You can say that. Yeah. How do you find this? I have just explained this clearly in the previous sessions also. Just check it out. This path, this complete left will be a root locus path, right? So we have also done seventh point. What was the seventh point that we have done? Existence. We can also do this before. Existence of root locus on real axis. Right now, how many poles are there? You have 3 poles. You just have to remember one more point here. Every root locus path will start at a pole and end at a 0. But do you have, we have 3 poles. How many zeros are there? No zeros. We will assume these zeros at infinity, and that is the reason we find asymptotes. These poles has to reach this infinity, and they do not know how to they reach it. So we have asymptotes to guide these poles to reach this infinity. So existence is completed. Now you can say that then you can find the point of intersection of root locus with imaginary axis. Now how do you do that? You know g of s. What is g of s is equal to k by s into s square plus 3s plus 10. Now find 1 plus g of s into h of s, characteristic equation. So s cube plus 3s square plus 10s plus k is equal to 0. Apply RH criteria. You also have other methods. This is one method that I'll generally follow. You can also follow the other methods. So s cube, s square, s power 1, s power 0, 1, 10 just now we have discussed. Next 3k, what is this value you get here? 30 minus k, 30 minus k by 3, 0, this is k. So you'll have the point of intersection of root locus with imaginary axis is obtained if you have all zeros in a row. You have to have all zeros in a row. Can I take, if k is equal to 30, can I say if k is equal to 30 here, this row will be a 0? Yes. So at k is equal to, this is called as the marginal value, k is equal to 30, s power 1 row will be have all zeros. Then you can say, then you need to consider auxiliary equation. What do you consider auxiliary equation? So this is 3s square, because you have s square, plus k into s square, s power 0. What is k? 30. So 3s square plus k into s power 0. So what is this? 3s square plus 30 is equal to 0. So 3s square is equal to minus 30, s square is equal to minus 30 by 3, so that is minus 10, and s is equal to, what is the value of s? So let's take one calculator if we have. Yeah, now let's take this calculator and try to find. So this is minus 10, you only have the basic calculator. So let's try to find this value. So what is that? We need to find root over 10, right? So root over 10 you can find, that is 3.16. So you can say this as plus or minus j 3.16. So it will intersect at the root locus, which will tend from this point, will intersect at 3 point plus j 3.16 and minus j 3.16. So these are the points of intersection of root locus with imaginary axis. So one will go along with this 60 degrees, other will travel along with this 300 degrees, other pole will travel along this 180 degrees. So this is the direction of root locus. This is the direction of the second root locus path, third root locus path. And these points are, what is this point? Minus j 3.16. This is plus j 3.16. Point of intersection of root locus with j omega axis. So you also need to find the angle of departure and also the angle of departure at these both complex conjugate poles. So how do you find that? So let's try to do this. So if there exists, the question here you can see in the question, number of centroid we have found it, yes we have found. Number of and angle of asymptotes, yes we have found. Number is 3, angle is 60, 180 and 300, and centroid is minus 1 comma 0. Breakaway points, because this does not have breakaway, for the breakaway points to exist the root locus must have two poles adjacent to each other, and there must be a root locus which does not exist. Then we need to find the angle of departure, angle of departure. So let's try to do that. So let's try to do that. Yeah, this here. So let's try to find angle of departure. Why do we have angle of departure? Because we have poles here, the root locus is starting from this. If we had complex zeros, we'll have angle of arrival, but because we have only complex conjugate zeros, we have complex poles. Therefore departure will exist. If there was a zero, we have angle of arrival. So let's try to do that. So what is that is phi d is equal to 180 plus phi, and this phi is equal to sum of angle made by zeros minus sum of angles made by poles. Now how do you determine this? Let's see. Let's say we have these points. I'll consider the pole 0 plot. You have a pole here, you also have a pole here, you also have a pole here. Now this distance is 2.7, this distance is 1.5, and this is, yeah. What you need to do is you need to draw lines from the other poles to this complex conjugate poles, right? Yeah, let's say this is, and you need to find these angles. This is 5p1. Do you have zeros? No, we have only poles, so this is 5p2. Now can I calculate 5p1? No, you cannot directly calculate this, but I can tell you that if this angle is 5p, let us say 5p dash. Now what is 5p1? 5p1 is equal to, we need to calculate these angles with respect to the positive real axis. Just remember that. That's the reason we have taken 5p1 like this. So 5p1 is equal to 180 minus 5p dash. If I subtract from this 180, total 180, if I subtract this, then I'll get this 5p1. Yes. So first I'll find 5p dash. What is 5p dash is equal to? It is opposite side by adjacent. Tan 5p dash, let's say. Tan 5p dash is equal to, what is the opposite distance? 2.7 by adjacent 1.5. 2.7 by 1.5, we'll get 5p dash is equal to tan inverse 2.7 by 1.5. So let's try to do that. Tan inverse, first let's calculate 2.7 divided by 1.5 is 1.8. So inverse 1.8, right? So tan inverse of 1.8, so it is 60 degrees. It gave us 60 degrees. Now what is 5p2? Can I say it as 90 degrees directly, this angle with respect to this line, right? So this is 90 degrees. So you just need to apply this. Do you have any zeros? No, it is 0 degrees. Minus 5p1 plus 5p2. We did not calculate 5p1, we have just calculated 5p dash. 5p dash is 60. What is 5p1 then? 5p1 is 180 minus 60 is 120 degrees. So this is 0 minus 120 degrees plus 90 degrees. This is minus 210 degrees. Phi is equal to minus 210 degrees. Is this because this is a negative angle? It should be minus 210 degrees. So you have calculated angle of departure also. So let's try to find angle of departure. So this is angle of departure also we have found from this problem. So this is how we will determine angle of departure and angle of arrival also, we can say. So finally I can tell you, in this session we have solved, in this session we have learned RH criteria and root locus, right? So we have done this 5 here. So you need to calculate this phi d. Simply just substitute this here. So phi d is equal to 180 plus 5, that is minus 210. We did not do that, I guess. So somebody was just reminding me. Thank you. Thank you for reminding me. Yes, we did not do that. Yeah. You can just substitute there. So that is, so phi d is equal to 180 degrees minus 5. This phi you need to substitute it here. So that is 180 degrees minus 30 degrees. That is minus 30 degrees. So because it is a negative angle, it will be in clockwise direction. So you just you want me to show it? Yeah. So you can say this angle is 30 degrees. So this will be plus 30. This is a clockwise movement and this is an anti-clockwise movement. Here phi d is equal to minus 30 degrees and here phi d is equal to plus 30 degrees. It will get the exact opposite of this. So this is anti-clockwise direction. Sorry, this is clockwise direction, negative angle. This is positive angle, anti-clockwise direction. So we are correct. Now, so thank you. Thanks for reminding. So in this session, we have learned RH criteria, all the cases with problems from the previous question papers, and root locus, one problem with at least few parts, like apart from breakaway point, rest of the points have been done in this. So this session is very helpful for the students who are writing the semester exams, and thank you all. So we have learned in this chapter 2 control systems, quick revision of RH criteria and root locus. So I guess this was very helpful to you guys, and as I always tell you, we have #1 study channels on Unacademy, and do like this video, share this video, and don't forget to comment and like and share. You can use my code if you are opting for plus and iconic subscriptions on Unacademy YSK10 to get the maximum discount, and also click on this bell icon to get more notification of my classes. And you can also join us on Telegram for the updates on upcoming videos. So let's crack GATE and ESE with India's largest e-learning platform, Unacademy. Thank you all. Thank you so much for joining me today on this session on Chapter 2 Part B revision for semester exams of Control System Engineering subject.